la 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 la. Hello. La 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 la. Hi everyone, welcome back. If you're new here, my name is Karin and this episode will be about animations and how they work. Don't forget to subscribe so you don't miss any updates. Now, let's dive into the episode. First, as usual, a quick recap, but this one will also contain some fixes I forgot to add from the previous episode. We began the last episode by importing the player sprites into the project. Then, to use this image, we made a method to import the image file into the code. And here is the first fix we need to address. As the Discord user BlazeDave pointed out, we need to close the input stream after we've used it. And we will extend this try and catch with a finally section. And the code inside finally is always called even if there is an error. So this code will always be called. But we need to have a try and catch for closing the input stream as well. Just in case the input stream failed and then we're trying to close something that doesn't exist, then we get another error as well. On the left you can see the old code and on the right you can see how it should look. And the reason behind the close method is to free up resources and avoid problems. So close it we will. Good feedback, thumbs up. After that method was done, we can then use the image. First we just drew it like normal, and then we draw smaller sections of that image, called sub-images. We also changed the size of our game to 1280 by 800 and talked about why it's better to set the size in our game panel instead of our game window. And that pretty much sums it all up. We will continue working with images in this episode as well. And as the title suggests, we will create animations. But before we start coding, let's just explain quickly how animations work. The simplest one, and the one we will use, is that we will store all sprites for that animation in an array. And every index of that array is one sprite. Then, as the game goes on, an index ticker is increased every update. And once that ticker have reached the desired value, the index of the array is increased by 1, and we draw the next image instead of the previous one. That way we will have a loop going through the array and making it look like the character is moving. So let's get our first animation going. And before we can even draw an animation, we need somewhere to store it. So that's the first thing we're going to do. And we can actually remove this sub-image. We're not going to use it anymore. And let's go down here and just remove that section, but let's comment that out. Right underneath our import image, we're going to have a method called load animations. And let's create that method. And as the name of the method suggests, we're gonna load our animation array here, but we need to create one first. So private buffered image. And the name of this array will be the name of the animation that we are going through. So the first one will be idle animation. Let's just call it Annie for short. And this array will be initialized inside this load animation, but we need to know how big this array should be. And if we take a look at this sprite sheet we're using, and the first row here, which will be the idle animation, have 5 sprites. So the size of the array needs to be 5. Equals new buffered image and 5. And to load it, it's not very difficult. We make a for loop. Int I equals 0, 0, I is less than idle Annie.length I plus plus. And idle Annie and the index position we are going through is equal to image, which is our atlas. Maybe we should rename it, but whatever. Image.getSubimage. And to get the correct position of each sprite, we're gonna say I times the width of the sprite, which is in this case 64. So 0 times 64, well, that's 0. And since we're only going to use this row, we're never going to mess with y. So y will always be 0. So the first one will be 0 times 64, 1 times 64, it's 64, and so on. So I times 64, and for y, well, 0. And the width will be 64, and the height will be 40. Let's say that, and let's go down to our pin component and give it a try if we can draw some sort of image from that array. So idle animation, and let's select number 2, because 2 is like pressed down, so this one will be easier to see. So hopefully we will get this guy. X delta, Y delta, and the width will be double and the height will be double, so it's easier to see. And we did. That guy looks very much like that guy. Yeah. Perfect. So we know the array is working. Wonderful. But this is not much for animation, so we need some way of looping through the array over and over. So let's create some sort of index variable that increases over time. And currently we have no update inside our game loop, but that's okay. We're gonna add it later. So let's just ignore that for now, but we're gonna add a update in here. So update animation tick. Something like that. Create the method. Let's bring it up a bit so we can see it. And let's remove the comment, but we're gonna store the variables up here. And we're going to need 2 variables. Private int animation tick, and then animation index. Actually, we need 3. We need a speed as well. That will determine how fast we're going to animate. The fastest we can do is once per frame, but if we do that, well, it's just gonna look very messy. So we need some sort of animation speed. The lower this value will be, the faster the animation will be. So let's just set it at, we got 120 frames per second, so let's see, 4 animations per second, that would be 30. Big math. And in our animation tick, we say any tick plus plus, then if animation tick is more than or equal to animation speed, then we say, oh, we need brackets too. We need some brackets. Then we say animation tick equals 0, so we reset it. But we need to increase the animation index by 1. And in case animation index is more than or equal to the size of the animation array, in this case the idle animation, and the idle animation is 5, so we cannot get larger than 5. So we're just gonna put it at idle animation dot length. So in case it gets equal or more than that, we say animation index is equal to 0. So it resets again. So it's gonna go 0, 1, 2, 3, 4, but as soon as it gets to 5, it goes to 0, and so on and so on. And then instead of saying 2, we say animation index. And if everything is working properly now, we should have some animation going on. And we do. It's a bit slow, so let's increase the speed. Let's try 15, so half, or twice as fast actually. So yeah, that's much better. Now we have one animation going. Let's add all of the other ones as well. And if we were just to go up here and add yet another array, say running animation, then we have one for dying and maybe getting hurt, etc, etc. That would be a lot of code. So we're gonna rename this array into just animations. And animations array will contain all of them, but it won't be a one-dimensional array, it will be a two-dimensional array. And we of course need to resize this to the array, and it's not going to be 5. So let's take a look at our sprite sheet to see how big it needs to be. So we got 9 animations total, so that means the Y, if you want to call it Y, will be 9. And then we had 5 here, 6 here, 3 here, 1, 2, etc. But we're gonna go with the one that has the most, so 6. So 9 in Y and 6 in X. And some of the indexes inside our array will be completely empty. Like here we have 3 spots, here we have 1, here we have 5 spots that's not going to be used. But they're still going to be added into the array, but that's alright. We're never going to see it anyways if we do it correctly, so we're going to manually set how many sprites there is in this type of array, and then it's going to just go that far. So we can probably just add another for loop above this, for int j instead of I equals 0. J is less than animations.length, so that's gonna check for the first dimension, or the outer dimension if you will, and j++. And the second loop here where we have I is going to go animations, and then we're gonna pass in j, and it's gonna look for how big that one is. And so instead of idle animation we say animations I, but we need the j as well. J I equals subimage get I times 64, but we also need to go with j times 40. So this is how we're going to get all the images of the sprite into the animations array. So let's go down here once more, and let's just comment this one out. We're going to get into this soon. And instead of idle animation we say animation, and not animation index, but we're gonna manually set it. So let's try and get a certain type of sprites. Let's see if we can get this guy here just by looking at the sprite atlas. And of course there's not gonna be any animations, but let's just see if we can get him. So that means 0, 7, 1. So 7, 1 should be that guy right there. So let's see. So 7 and 1, and let's draw and see if we get him. And we did. Let's see if he matches. So we wanted this guy. Let's see if I can get it lined up a little bit better. So we wanted this guy and we got him. Perfect. So now we know that the animation array is working. Now we need to work on a way of looping through it. So let's do that. And let's just uncomment all of this. So let's keep everything intact except this section right here, where we say idle animation.length. We're just gonna say 6. We have no way of switching the type of animation just yet, only manually. We can only do it manually. So let's take a look. The running animation, which is actually 6 sprites. So 1 for J, and for X we're going to go with any index. So let's see if we have our running animation working properly. And we do. Beautiful. That is one pirate that loves to run. But we still have no way of changing animation depending on the action of the player. For example, if we are running with the player, well, then we should have the running animation. And if we're standing still, then we should have the idle animation. And we can't go into the code every time we want to change that. That wouldn't be a game, that would just be nothing. And we need to do a few things in order for that to happen. So first, we're gonna create a new package called utils. So we have utils, and then we click finish. And in this package, we're gonna create a class called constants. And we're gonna click finish. And this class is something we're gonna come back to many times. And in here, we're gonna create another class, an inner class, if you will. So public static class, and we're gonna call it player constants. And we're gonna add brackets to it. And everything in here will revolve around the player. And in here, we're gonna create our first static value. So public static final int running. So the static value for running will be 0. And we need one for idle. Static final int idle equals 1. Let's see what else we have and in what order. We have jumping. We have falling. We have falling to the ground, so ground. We have one for getting hit, so hit equals 5. We have one for attack 1. We actually have 2 attacks, so we're going to call it attack 1. And we have attack jump 1 equals 7. And then we had attack jump 2 2 equals 8. We had 2 different attack jumps, and I don't know if we're going to use them, but it's good to have them in here anyways. And I look at the raw files, and there is more animations that I have forgotten to add to the sprite atlas, but that's okay, we can always add them later on. Now we have one ID per animation, so if you're running, then we can check if it's running, and then we can pass in running and we get back something else. And we need a method that returns the amount of sprites per animation, or the animation we're asking for. So in case we're asking for the player is running, how many sprites are there in this total animation, so we don't go over or get some type of out of bounds error. Public static int get sprite amount, and we pass in int player action. And the reason why I have a uppercase G here instead of a lower is that whenever I use this method, I understand that, this is a static method. Okay, let's use something I like to do. And if you want to go with a lowercase, that's completely up to you. And this indicates that there is some sort of variable that I'm going to pass in here that's going to ask for a player action. So you can do it how you want. I like to do it when it comes to static method and using it as a check. So without further ado, let's continue. Switch, and we're going to switch the player action. So depending on what type of player action, which all of these are, he could be running, he could be idle, jump, etc. We're going to pass in the player action in case it's running. Then we will return how many sprites there are in this animation, so we don't, go out of bounds. So let's say case running. And I'm just going to do all of this and get back to you in a second when I have all of them. And there we go. So you can see that we have one animation that have 6 sprites. So we're just returning 6 if it's the running. And we have one with 5 and one with 4. But we have 4 different animations that all returns a 3. And this is what's nice with a switch, is that you can have more cases than just one that have the same output. So jump, attack 1, attack jump 1, and attack jump 2. All of them have a animation with just 3 sprites. And then ground have 2 and falling have 1. And in case we input something weird like a 7 or whatever, then we have a default that returns 1. So that's why. And I think we're good with this right now. So let's go back to our game panel. And for this to work, we need some global variable. We have no player class, so we're going to do all of this inside game panel for now. And when we add more of a player class, we're going to move the code into that. So let's just code this out. A global variable to contain current player action. So private int player action equals, and then we're going to use one of the default one, which was idle. And we need to get that correct constant, and I think we're gonna need to import it manually. So import static, because we don't want to type it all out. So import static utils dot constants dot player constant, and let's go with all actually. So dot star means you import everything in that, in this case, class. So we get all of these, and we also get this method that we can just call without calling, constants dot player constant dot get sprite amount. So back to our game panel here, and now you see idle got recognized, and we just hover it. It says utils constant player constant dot idle, and its value at 1. And in the paint component, we're going to replace 1 with player action. And animation index we can keep for now, and we're gonna be able to change these in a second, but let's just try if it works. We've done a lot of code, so let's just try it. And we have no errors, and we have a running animation going on. Why is that? And that's on me, because the first row here is actually the idle, the second one is running, so we need to move those over and say idle equals 0 and running equals 1. That was my bad. and let's restart it. Now we should have an idle player. And we do. And the reason why he is flickering a little bit is because if we take a look at our game panel, where we have the, where is it? Here, update tick. We have it up to 6. We haven't been able to automatically set this, so it goes to 6. But if we take a look at the player animation, it's actually only got 5. So now is the time where we call get sprite amount int player action, and then we place in player action. So that's where this one comes in. So depending on the player action, we now get a different amount of index as a max index in that animation. So if we try it again, now he should not flicker. And he does not. So it goes only up to 5, which is perfect. Very, very good. You know what? He's still kinda small. So let's double this again. 160 and 256. Just so it looks better and we can actually see him a lot better. Like so. Now we can see him much better. So the animation is working perfectly. Now we need to change his animation depending on what we do. So in case we're moving him like I do now with my keyboard, he should change his animation. So let's give that a try. And this we will achieve by changing how we move the player. So whenever we press any of these keys, we change the delta for that direction. But we're gonna change this into something completely different. So in our game panel, we can remove this set rect position. We don't need that. We can remove change x delta and y delta. And here we will simply add another method called public void set moving, and we will pass in a int value, int direction. We can call it direction. And depending on what direction we're setting inside our paint component, we're gonna check is it to the left or is it to the right, and then move accordingly. But we're gonna need a few variables, and we need to go to our constant class and add another class, inner class in this case. So public static class called directions. Directions, yeah. And we will just have 4 values. Public static final int left, right, down and up. So left will be 0, and we can just copy this. Left, up, right, and down. So you're going clockwise. So left, up is 1, right is 2, and down is 3. And we don't need anything else. And then we can go back to our game panel, and at the top here, we need to import that as well. So let's just copy all of this. But instead of player constant, we say directions, like so. So now we have all of those directions. And we also need a private int player direction. And we're gonna set it to -1, because if we're not moving, then we're idle. So that would be -1. So if we're not moving, -1. If we're moving, it's 0, 1, 2, or 3. All we do here is say this dot player direction equals direction. Actually, we should call this set direction instead, not moving. And in our, we can go to our mouse inputs first and just remove this one that we will never use anymore. Then we can go to our keyboard inputs. And for W, we're going up. So game panel dot set direction, and direction was up. So let's just import that as well. Import static constant directions, like so. So now we have set direction up. Copy that. A is left, S is down, and D is right. And let's copy all of this into key released. So whenever we press a key, we're setting a direction, and when we release that key, we're saying no directions, or we should not be moving anymore. So we just remove all of this. And we will actually have yet another variable. So player direction and then private boolean moving equals false. And whenever we set the direction, we say moving equals true. And then we need a method for saying moving equals false, or setting the moving to false. Public void set moving boolean moving. And this is a simple setter, so this dot moving equals moving. So let's go to keyboard inputs again and say game panel dot set moving false. Just like that. And then inside our paint component, we're gonna do a check. Set animation. So one that's updating the tick, and this one is gonna determine what type of animation we will have for this frame. We're just moving that method up here. And if moving, then we wanna say player action equals running. Else player action equals idle. But before we run it, now we need a way of increasing or decreasing deltas. So update position. And we create that method too, moving it up. First we'd simply check if we are moving. If we're not moving, then we don't need to go any further. So if moving is true, and then we do a switch for the direction. So switch player direction. So case left. Oops. Case left. Need a break. So left, up, right, down. And if it's left, then we want to say x delta minus equal 5. If it's up, y delta minus equals 5. If it's right, it's x delta plus equals 5. And down is y delta plus equals 5. I think that's xy, yeah. Yeah, that looks alright. So now we can give it a try and see what happens. So I'm just idling. Let's see what happens if I start running. And we have a running animation. And I let go of the key. So running, left, down, right. That looks beautiful. Perfect. Alright, that was pretty much all we needed to do in order to get the animations working in the game. Sure, we added some extra methods and variables in order to change the animation depending on whether we were standing still or running. It is worth knowing though that this is not the final version on how we will check the player's behavior and then select the animation that fits. It is, however, easier to see and understand how it all works with this code. If you're still watching now, I would like to say thank you for watching this episode. I hope that you learned something useful today. In the next episode, we will add the update method to our game loop. So don't forget to subscribe so you don't miss the next episode. And of course, if you enjoyed it, hit that like button. Until the next episode, take care now and have a wonderful day. Cheers!